It says I'm live, but it throws a bunch of errors at me. So we must be live. I have to go check.
Yeah, let me check.
Yes. Okay. Hello, everybody. Do you see us live? Are you seeing a YouTube window there?
Yeah, I'm checking the YouTube now. Yes.
Okay.
Okay, I see myself in it now. Oh, awesome.
Perfect. Hello, everybody. This is our weekly Wednesday. I'm Sudha Jamthe, and we have been talking about AI models and how to get to the AI models from your data, just to go through specific AI models one per week to get to the bottom of it. So here we are. We've covered anomaly detection for last 2 weeks, and now we are going to be talking about personalization AI models. Okay, so for those of you who are joining me new, I'll just give you the rules. There are no rules. So you join on YouTube and you can see the chat window. You can type, introduce yourself. The beauty of this is we have people from around the world who are joining, who are from different industries, different aspects of AI, from various different roles. So it's as much as learning from other people and sharing your experience and networking from the community as much as asking me questions. Other than that, you can ask me any questions. And today I have a guest, so I will be talking to Patrick, and I'll periodically check what your questions are, comments are, and then try to answer that. And answering your questions is our highest priority. But we have Patrick Slavenburg.
Yes, hi there.
Hello.
Holland.
He's here.
Nice to be here.
Yes. And Patrick has been here before as our guest, and Patrick has been a regular typing away on YouTube. So he's not a stranger, but we'll get started in a minute. And the beauty is, I've been telling everybody, this is my new book. This line is
it, guys,
the author
buy it.
copy. It says not for sale, but when you buy it for real, you won't get this line up there. AIX, my new book. I'm very thrilled that it's finally out. I can get some sleep. And I am so thankful to so many people who've been helping me, who believed in me and just made sure I just was done with this and got this out. And AIX, as it says here, is about designing artificial intelligence. So there is one aspect of AI, which is the UX or AIX design, which I teach in the AIX class with Dr. Charles Ika. And to get there, we need to start from data, build the AI models, and figure out how do we fine tune the algorithms to get to a high degree of confidence. So here in Weekly Wednesday, that's what we do. We are started with one algorithm per week, and we are continuing. And if there is need, we will continue the same model again till we get to the bottom of it. And so Patrick has a case study in here. We have about 10 case studies, and Patrick has a case study about personalization AI for a retailer. And it has been an amazing experience. It's one of my favorite case studies. That's why I invited Patrick to join us today. So Richard is here. I'm going to say hello, and he says hello. Richard Mayers is here, and he is my editor for this book, AIX. And so you can see if anything is different, better from my previous books, all credit goes to Richard. Okay, so let's get started. And you've tested that you're able to see the YouTube, right? Richard, if you're able to check whether YouTube is fine and it's streaming and people are there, it'll be helpful. I appreciate that. And I'm going to go in a minute once Patrick gets started and check who's out there. People usually take some time to warm up. If you're new, you typically don't feel like introducing yourself. You don't have to do anything. If you don't want to comment, you can just listen in. That's okay too. But if you comment and get to know other people, there is more value, especially if you have worked with personalization or any form of recommendation algorithms, we want to hear from you. And there's no right or wrong answers. And if you think you do something different and your experience is different from ours, we are fine. You can, all my students know that you can interrupt and ask questions and fine. Okay, thank you, Richard. Richard just double checked that YouTube is working fine. So with that, I am going to hand over to Patrick. So Patrick, give us a little intro. I know you have a very complex intro because you worked round the clock.
Yeah, so, okay, this was the deal. We had a catalog. We were a platform, like a marketplace. So a marketplace means you have buyers and you have sellers, and there's a whole community of sellers, just like eBay and Etsy and all that.
Sorry to interrupt. Before you go into this particular case study, give us like a 2-line background of who you are, because you're always talking to me about various models, and I know you have a long history of working across continents, literally across continents.
Yes.
But tell me your background relative to AI and algorithms.
Oh, related to AI and algorithms. That's actually relatively new, and it's a little bit old. I caught fire watching Star Trek. Okay, and who doesn't want to explore and discover all these new planets and develop these technologies that propel humanity, right? All these cool technologies. So that's why I started studying physics, laser physics, got a master in laser physics and theoretical physics. And there too, I did some computer calculations mid-late 90s that were similar to what machine learning is now. After that, however, I was kind of discovered that I'm more of an entrepreneur or, explorer than I'm a scientist. And so I went working in business. And that's basically all the business areas that I worked in always had to do with exploring new opportunities somewhere. I ended up in San Francisco as a consul for the Dutch government. And there too, I had to sort of grow the business for Holland, which meant large investments in the Netherlands by Silicon Valley companies or LA companies. Okay,
and this was what time period? This was long ago.
This was a little bit longer ago, till 2007. And then we switched to our own startup. And that's the one that this business case of this machine learning use case is the use case of.
And you also worked in Latin America.
Yes, that was also a little bit longer ago. So I've lived in different countries. That's why I said the discover, explore, the sort of new business opportunities was a bit more than sitting in a lab and doing research. I've always tried to be sort of, when I got back into the new startup, which was called Farlang, which is Yiddish for too long for, or linked to the Germanic words verlangen in German and Dutch, which kind of means too long for in English. So you can see the origin of the words if you change long and for. And in Yiddish it means wish of desire. And we were a luxury website, so wish and desire kind of felt appropriate.
Okay, so tell us a little bit about it and tell us about the team, and then I'm going to mute myself out.
Let me first tell a little bit about the case, or a little start about the case, because then people know if it's at all interesting for them to stay, or if this is what you want to hear. And I'll tell about the team later, but it can also be in. I'm sorry, I suddenly Sudha disappeared. Okay, I'm alone.
You're in focus, so go
right. I'm the focus. Apologies for the distraction. The case study was that we had a catalog for marketplace that we were. In our case, it was jewelry, so not exactly something that you think is high tech. And it was fine jewelry. They were all expensive stuff, and they were all one of a kind. And the problem with that is, how are you going to recommend something that doesn't follow the normal rules that you can find on Amazon or Etsy or whatever, where there's a lot of mainstream products, and these mainstream products are often visited, and therefore you can base your recommendations on the behavior of others. That's called collaborative filtering. And it goes something like this. Let's take a food example. Suppose you like sushi, you like green curry, and you like, let's say, tandoori, okay? And the fourth thing you like is satay. So now I'm visiting recipes for green curry, sushi, and tandoori. Then it makes sense to recommend to me the satay, because we have that in common. And of course, you do that with two people, but obviously, in the cases of Amazon's or large e-commerce sites, it's thousands or hundreds of thousands of people that click on a group of products, and therefore you can sort of find in that group of products the overlaps, the similarities, and then we recommend that to them. That works well in two scenarios. It works well in the case of mainstream products that are visited a lot and that don't have very unique characteristics. And
sorry to interrupt. So since we are talking personalization, I don't want to assume everybody's on the same page. So personalization as an algorithm when we are building is essentially a form of recommendation. So one of the things that I try to demystify in the book about algorithms is any kind of AI, machine learning, deep learning that you're doing is actually trying to solve 3 or 4 kind of business category of items, of problems, right? So there's a lot of predictive algorithms, prediction, we are not talking about that. It's a form of prediction essentially in the end, but general prediction that you would run prediction models. You can run anomalies. We've talked about anomalies last weeks, right? Recommendation is one huge category, and e-commerce and marketplaces is all about recommendation. I come from, my love of data is from what I've done with eBay, which is a marketplace. So, I go back to that again. So I'm familiar with various forms of recommendation algorithms. So what you started talking about is item-based. So in Amazon, you have different kind of recommendations that they give. And one of them is item-based. You can either do item-based or content-based. And that's what you see on Amazon. Both of them you see on Amazon. And the third one is social. You made a point about it is between two people. That could be a social algorithm also, right? So, between Patrick and Sudha, there is a high propensity if you end up talking about food and then you give food algorithms. Could be one thing. I mean, so I just
so the idea was, and those are the typical algorithms. They look at what people visit, and if there's an overlap in what they visit, then the assumption is that if you visit something, you like it.
Yeah.
And therefore, we're going to share all these items that you could potentially visit and others have visited stuff that you also visited. Okay.
So the reason I wanted to bring this up is for an eBay or Amazon, when they have a huge history and you have a historic customer database, then you can actually go and look at the customers overall and say, hey, people who bought this also bought this,
exactly.
Right? That is one, which is again item centered, but based on people, right? It's not specific to me, right? So when I go into Amazon, even if I'm a new user and I don't have any history with them, they can still give me a recommendation based on their huge database of customers. The other thing is item based is people who bought this also bought this. That's the upsell that typically that e-commerce sites do. And that is again independent of the customer, right? So people who bought this, bought that, meaning the first time I make a purchase. So when I buy my book, then it actually says, hey, this other book by David Kerrigan was bought by a lot of people. So maybe people will like this other book. And so it gives a item-based recommendation. So the point I want to make is when you get started, you were saying this is a whole new startup. You still have the opportunity to fill your page and show so much and move people with recommendations to engage and fine tune your data points of whether I made this recommendation, she didn't like it. I made this recommendation and she liked it. And you're starting to build that customer preference data in your data set. So when you got started, did you do item based is where I'm going, because you said you had 3 versions of it. So
Well,
I wanted to set the stage
yeah.
for people to know the item-based or content-based and the social recommendation as three different options of doing recommendation before you personalize the experience.
Well, what we did was we did item-based, but we had to do it a bit differently. And that was already the first innovation, because normally the data, so we had a market.
Hello? No, I lost you for a minute.
Okay, and there was all these individual designers.
Sorry,
These
sorry,
individual
Patrick.
designers were
I don't know
very
if it was.
high-end.
I don't know if it was me, but I lost you for a minute, so you might want to
Talk
repeat.
about stuff that's okay. Yeah, am I back?
Yes.
But I do see. Yeah, okay. So we started out initially as a marketplace, and the marketplace had tons of designers, hundreds and hundreds of designers with very unique material. So there were more artists actually than maybe individual designers, in the sense of very traditional designs you see in every store. It was also very expensive stuff, $1,000, $10,000, $100,000. On top of that, a lot of times they were one of a kind. So you couldn't really say people who bought this also bought that, because if they bought it, no one would ever buy it again. There were limited editions and all that, but a lot of it was unique. So it was a different context. If you remember maybe Chris Anderson's story, early 2000s, about the long tail, which basically is you have a peak of best-selling products and then an enormous tail of products that rarely are sold. And that's what Amazon does. It pushes you into all that product tail with stuff that's rarely sold. And in that way, you discover products you would normally not discover, because, for example, in a normal store, there's no space for that. Now, our product was more or less completely long tail. It was a very fat, long tail with unique stuff. And so how do you start correlating that? How do you recommend something to somebody else based on what you know? So we decided starting with the user is probably not the best way.
Yeah.
Also because you don't know exactly why people behave the way they behave. And for us, when we started doing personalization in the next step, we really took into consideration the cognitive processes and the emotions rather than just the behavior. Because if something is ugly to you, you will also click on it. If you use that in your data, in your big data, in all these traditional machine learning algorithms that cluster or whatever, that's noise, because you assume it's a good thing, but it's not a good thing because they disliked it. We started with the items, and we had to find a language, common language, that we could express all these different items in. And all these different items were totally different. You know, very ornate, very minimalistic, all different designs. European, American, Asian designers everywhere. And we discovered that in design theory, in art theory, there's a thing called design principles and design elements.
Yeah.
And the elements are stuff like circles or curves, rather, or direct straight lines, that kind of thing. So really elements of a design. And principles have to do with how you combine these designs. So whether there's a balance, a symmetry, whether it's geometrical or asymmetrical, or has a certain flow in the design. So that you hear these stories typically in art or in architecture. And being able to label, and that's what we did, every photo in that kind of language, and if you then start clustering it, then you suddenly have a different way of clustering items than you would normally do with the normal data that's linked to a product, which is size or the elements that are, the stuff that it's made of in our case, so gold with a ruby or an emerald or whatever, and who made it and when it was made and how much it costs. And typically all these things that you see on all the e-commerce sites are basically database features, variables that are necessary to identify the item, but that doesn't really identify an item, does it? So how about being able to describe the item in a language that you can then organize the different words that describe that item with, and then find similar looking items. Because our assumption was, if somebody visits a page, so that was the first assumption, that was version 1.0, then they can either love it or they hate it. So it's kind of like a binary decision, okay? All we can do is, well, if they hate it, then there's really not much you can do anyway. But if they like it, then what we could say is, well, here are designs that you might like as well, because they are composed of similar elements, and the elements are structured in a similar way as this item. So a minimal design, let's say from Sweden, would not easily end up on the same page as a very ornate design from a Latin American designer or a Middle Eastern designer. Simply because how it's built up with a lot of curves and the details and the symmetries is just very different in a Scandinavian, typical Scandinavian designs, as in the Middle Eastern designs or Latin American designs. So automatically you would get a clustering that, at least on a gut feeling, on a visual level, would feel somewhat similar. And then you would be able to, you hope that people then click on it because they find something that that resonates with them, that they can connect with on an emotional level.
Patrick, sorry to interrupt. Hold on for 1 minute. I see people on YouTube, so I want to see
it's
whether
a good moment to stop anyway. So
okay, so oh, Patrick, you were there before we got started, saying you were not able to connect. So I'm glad you're here. David Kerrigan is here. He says congratulations on the book. Thank you, David. And Patrick also says congratulations on the book. Thank you. And Dalton says congrats on the book. Okay, thank you, everybody. Thank you so much. I really appreciate it. And Dalton says honored to be part of it. And Dalton has a case study. David has contributed a case study. So we will be going over each of the case studies. Again, we are talking about different AI models. So as we cover different topics, we would cover the various case studies. That's my hope. So thank you, everybody. So as you're listening to the recommendation AI, specifically as Patrick is describing how he went about getting to a personalization model, jump in, ask questions, or if you have experience in this space, type away, and I will periodically check and interrupt Patrick to make sure we get the question answered.
I have my eye on the YouTube channel as well. So
okay, so I can check that periodically for you. So that's fine. Awesome. Making myself useful here. So you were talking about how you did not have any content, and the items you have is also not any content, any users when you got started, like any new startup, and then your content is very unique, and based on that the first version was to arrive at, can you find similar items?
Yeah, so can you find similar items, and similar is defined as by design, because
what do you mean by design? How do you empirically define the by design?
Well, this is, and we didn't do this all the way in the beginning. It was actually after a couple of years, because first of all, we need to collect more data, and second, there weren't just that many designers that you needed to, send recommendations out if you have a way to browse it very quickly. What I mean,
you had a recommendation. So the one thing I did right when you told me about this case study, that there were 3 versions, and yours was unique because it ran over many years.
Yes, so it did.
You were able to sell, you had customers testing it out, and you started building data while you were going through this, right? It was not just a test and iterate pilot mode.
No. We used it, and we even used it offline in the retail store. So that's why it's a retail thing, but it's a little bit later, because similar designs per se is not something you can use in a retail store. But so what we achieved with that was a click-through, an enormous increase in click-throughs, a couple of 100%, but not necessarily, and this was one of our metrics. At that time, we didn't have a shopping cart for many reasons, but things went through special inquiries. And we had an increase of 10% in inquiries, but that's not a lot for all the work that's put into, because you have to label all these photos. And it's not somebody that can just label them, like you can't just send it to the Philippines or whatever, and then people label it. they have to be art and design students that can actually assess the different components that this design is built with. So what I mean with design elements are...
So again, sorry to interrupt. So you are touching upon a very important aspect, because when you get started with any model, first you start with data. And if you don't have historic data, is your challenge that you're talking about, the very first phase. And in your case, looks like you did not have a shopping cart. It was not a huge volume, low cost product. So it was inquiry.
No. There's a couple of things here. When we started doing the algorithm, we already had like between 5,000 and 10,000 items on there. And that made us the second largest in our niche. The only one that was larger than us was First Dibs, and they were a luxury site in general. So antiquities, furniture, and they had like 50 million in venture capital or something. So for fine jewelry, we were as big as it got. The problem that we didn't have a shopping cart had to do with the politics. And that's a very interesting topic, but it doesn't have to do with the algorithm, which is the jewelry industry exists of an ecosystem. And it turns out that you can't just take one stakeholder in that ecosystem and do something with them. You're going to have to, at least at the time, you're going to have to bring that whole ecosystem on board. And retailers weren't happy with designers putting prices online. And you need a price if you want to have a shopping cart. And the reason is that they bought it from these designers and then put their own price on it, depending on the local market. So they, at the time, and that at the time is even 2012, 2013, I'm not talking about decades ago, at the time, they saw the internet as a threat in the same way as catalogs were a threat in the 70s. And the best way to deal with the threat is just to ignore it and to say you can't do anything online. So what they could do online was present their work and create a means of communication. That was allowed, but not direct sales. That changed a little bit later, but it's a very, very, very complicated industry. And so this was one of the things that we had to deal with. That's why we couldn't do it. The other side of it is that no one is going to just pour a $10,000 item, if it's not a famous brand, in a shopping cart, put in their credit card, and go and wait for FedEx. There is a dialogue. So So
I see two things. One is the price of the item, and the shopping funnel was very different. So in a small price item, or if you buy something in Amazon generally, then you're top of the funnel and you're considering, you go shop everywhere, and so you're watching that funnel. In this case, because it is a expensive item, it was going to have a lot more deliberation. So like electronics category usually has a lot more deliberation because it's more expensive. And so in our case, it's $10,000 per item.
Yeah, and so our funnels were differently defined. We did have funnels, but we had to go about it in a very, very different way. And the way we did it had to do with how you build trust online. And we contextualized our site a lot. So we worked a lot with museums, with laboratories. We had a library online, a lot of stuff that you associate with trust, with luxury, with reliability.
Dalton is saying something. I just want to make sure I captured that. I'm sure all case studies mentioned will unlock several insights for all of us and for the readers. It's a rich source. Thank you, Dalton. It's a rich source. He's just saying wonderful things about my book and case studies. So thank you, everybody. And he's saying it's going to help the AI professionals and my Stanford students, because the book is going to be a textbook for the upcoming AI, Artificial Intelligence for Product and Business Managers course. Okay. Thank you, everybody. As you're listening to Patrick, we've covered, how do you do item-based recommendation, but what I love about our conversation is Patrick is actually talking about the thought process that went, the business acumen that went behind the scenes to arrive at the data to decide how to build the recommendation algorithm. And that is very, 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 very critical in any industry, any business, any kind of model. And I believe Dalton made this point very beautifully in my book. So when you listen to his case study and his quotes, you will see that is the training data is not something that you have sitting somewhere and an AI researcher will run it and create a model, and then you test the model. It works, it doesn't work, you improve the performance. And it does happen in some places, and it's very frustrating for everybody because it doesn't go past a certain amount of confidence, right? So you cannot run a model if it is only 60% confidence, and then hit or miss and you lose customers. So the thought process that goes in is what Patrick is talking about. And the other thing I heard from what you said, Patrick, is so I want people to ask questions or jump in with question comments. We welcome that. That's important for us here. The other thing I heard you say, Patrick, is I see a parallel with most retailers who actually have a retail store go through that process when they make the transition to online. So we have like an online offline commerce that with Walmart and many of the retailers here. I have worked at Harcourt, which is a textbook publisher. They went through the same process, and I helped build their the e-commerce business, what we called as the Internet Solution Division, a while back. And they had the same thing because they used to meet. Their sales cycle was to meet in person, collect inventory based on the expertise of these acquirers. And then they had a process by which they sold that in textbooks, legal textbook, medical textbook. They had different channels. And putting that online was impersonal. And what you said was very important, how you build trust with the customer. So its recommendation is not just, you put a bunch of things and let the customer click something. Every click is an acknowledgement the customer loves it or hates it. And it's a communication back. And people
and we definitely use that info later, but in a bigger context. Something about the accuracy that you mentioned, the 60% and all that. So let's say that you break down a design, and what I mean with breaking down in a design is you can translate it in lines or in shapes, in forms, in the colors that are being used, how these colors are being used, the symmetry or the asymmetry, whether it's a particular type of geometric design or a minimal design, and so on and so forth. So you can describe an item in that way. And what we used was what's called in machine learning a bag of words. And you typically use it in text, where you count the number of words in a piece of text and then find.
Is that something you made up, or is that an industry term? I've not heard it. Machine learning in a bag of words.
Bag of words is a way to do text analysis.
Okay.
Where you count the number of words in a text, and you exclude probably words like and the and all that. And then you find similar documents, and the similar documents are the ones with similar words and similar frequency. Okay. So it's the type of word plus the frequency, that matters. And you can put it in a vector. So you can put it like in a column below each other. And if there's another column that looks very similar words or same words, or synonyms and frequency, then you might have a text that's quite similar. That's still being used a lot as a basis for text mining and document retrieval and all that kind of stuff. So what we did, and it's also used in computer vision in a way that normally it's a computer vision algorithm that extracts then the shape, or other things that you define, like the symmetry or a combination of lines.
So those are basically textual attributes that you add to every item. So
exactly,
right.
And instead of letting an algorithm, because we looked into that, a machine learning algorithm of a computer vision algorithm, but the problem is that the photos that are taken from a product from all these different designers were, first of all, different quality, second, under different angles. So imagine that you have a ring and you look at a ring at a stone, a big stone, and then the ring underneath, or you look at it from the side, it looks very different. So how do you discern what the type and the style of something is if you have all these different angles? It's very, very, very hard. And
I didn't realize when we were talking about personalization engine that you were actually doing computer vision on the images, because I thought it was your product.
We didn't, because it was impossible at the time to even discern between a running horse and a standing horse, a standing still horse, you know, horse that was standing still. So let alone all these different angles, it was just not useful. So what we did is we used clustering algorithms and let the humans do the computer vision, which means they saw how a piece of jewelry, what it looked like, and what the design elements and principles were that were used.
So
now,
is this the human-based labeling? Because you mentioned sometime we could not send it away to Philippines or somewhere to the labeling. I'm sure there are like smart researchers and machine learning engineers who can build algorithms in Philippines as we are talking this, but the labeling being done by a human augmented labeling is still a thing. I mean, there's figure 8 here, and they offer human augmented labeling.
Yeah, or an ontology. What we did is we created an ontology, if you wish, or a visual vocabulary, as we call it, because ontology, people don't understand what it means. But we started with describe the design. Yeah, there's a circle in there in the top right corner. There's a circle here. It has a lot of spikes. Hey, it's symmetrical because there's a center, a color center, which means there's one color exactly in the middle that draws the eye. That's an art. In art, it's a thing, and you use gemstones for that, and so on and so forth. But if you talk about the clustering and the accuracy, because that's where I think sometimes data scientists go overboard, you think, okay, now I'm going to cluster it and I'm going to build the best accuracy possible. Yeah.
So by clustering, you're just basically grouping them. That's remember I said we can do 4 different things that algorithms do, right? Prediction, anomaly, and recommendation. Yeah. And clustering is basically grouping. I was,
yes. So
usually done with customers types, but you're doing with products.
You group similar looking products. That's all you do. And you could do that with airplanes or with cars or whatever. It doesn't matter. And how you do it is nowadays, of course, you do computer vision, but this was a couple of years back. It wasn't very good possible. I know Swarovski is working on something similar right now, and they're trying to do it with computer vision, but they have one big advantage. They own the catalog, which means they can define the photography and they know exactly how it's photographed, under which angles, and so on and so forth. So the standardization allows for computer vision to happen. If you don't have that standardization, like applied to eBay or Etsy and just a random set of products, it's going to be hell still. So now if you cluster that, right, and you think, oh, I'm going to perfect the algorithm and they make it 80% accurate. The question is accuracy in what? Because you want to connect with somebody's emotions or with somebody's taste. So ballpark, if somebody's into Scandinavian design, furnitures or whatever type of design, they're probably not into very ornate design, or grandmother's look or something. And or this, chest from the 19th century, with a lot of details, if they like modern, cases that have a minimal design. The question is, can you refine it to such a degree that you go beyond that and that you connect with exactly the thing they like? And that's very, very hard. So you're better off saying, ballpark, we have designs that are similar looking. And after that, it's actually a waste of time and resources to try to perfect it further and further, unless you can, somehow monetize it and the monetization makes it worth it. But
so coming back to the model, I just want to make sure that I'm on the same page with you. You set out to build the recommendation engine so it will personalize the experience for the user, so they will buy exactly what they want. In your case, the buying process was an inquiry because it was a $10,000 item.
Yeah.
And you started with identifying the items.
Yeah, but even if you have a shopping cart, it would still be very hard to narrow that down, because it's a weak correlation between how something is designed and what somebody likes. There is a correlation, right? If you're into Scandinavian design, you may not be into 19th century Victorian design, okay? Yeah. But it's not a given, it's not 100%. Now that underlying uncertainty in that correlation makes it very quickly, I think, or we thought, all of us, not so valuable to perfect the accuracy of an algorithm, because you might perfect the design elements a bit more, but there is still the link to somebody's taste that is not 100%, black and white given bridge that if you define your designs well enough, then they will like it, period. That's not the case. You can like
it's
a
not
lot of
causal.
action
Even
movies,
if there's a correlation, it's not causal, right? It has to
yes,
be.
exactly.
Yeah.
And for example, I can like a lot of action movies, and then the new, or I loved all the Terminator movies, but the new Terminator movie with Schwarzenegger totally sucked. So what do? You start classifying all these movies, you refine it, and you build a kick-ass recommendation engine that now gives me the last Terminator movie, and I still didn't like it. So there is not a black and white 100% correlation between my taste and that particular item, be it a movie or a product. Okay, so we had
So
to go.
how do you
So we went further. So
so
and that's where I
when
want to
you
go now.
so when you're actually building, getting the data and refining it further, the first step is, yes, you don't have customer data, you're figuring out how you're going to make some kind of item based assumptions and validate that to arrive at a model, right?
Yeah.
One of the things I have seen is people build a model with what they think they want to do, and then they don't arrive at the right degree of accuracy, and they are stuck. And that's a very common state. And so I heard something, maybe I'm just hearing it, so tell me if this is, off base. But the right metric you define becomes important, because you can tweak a lot of things, especially when you start getting more data and you're trying to arrive at what is causal of understanding the customer preference, which is very complex.
And not only that, but you have to know when good enough is good enough. And too many times, and I hear it all the time, even now with enterprise applications and all that, the data scientists just want to go on to get the highest level of accuracy. And it costs a lot of time to build these models or new architectures of different types of deep learning models. And it's not necessary, because the underlying uncertainty of the reality you're trying to describe can oftentimes be larger than the difference in accuracy you're trying to achieve with model optimization. So you're actually Mickey Mousing around with the model optimization when the underlying reality can shift and show earthquakes, and the whole model, wouldn't be working anyway in that particular case.
So
Okay?
just to be fair, for retail, it might not matter as much, because there are so many variables, right, of the preference of the customer that things can shift, that I might not even know that I'm going to like something till you actually put that in front of me. Even if you knew my past preference, from there you can see what my propensity to buy is and everything. And then you bring something new in front of me, it's an unknown, and I might have a different trigger. I might love it, hate it, or whatever, right? So for retail, I think that whole percentage of accuracy number might not matter. But in all fairness, when I see everybody trying to optimize the deep learning, machine learning models for healthcare or some other situations, even, if you're going to use a model to decide on prediction and say, okay, we are going to pull this plane of regular routine for unscheduled maintenance, then there is a cost to it. And I see a lot of arguments between the researcher coming with the model and the business people, or I've heard business the researcher saying, I've come with the model, this is perfect. I tell them, they don't believe me because they have that. So there's a whole human element of conflict that happens in the enterprise always, and it just exacerbated with data.
Let's use predictive maintenance of a machine. So a machine is predictable, the outside world is not going to change it. But what if somebody, and the machine is running in some factory, and what if the people in the factory are absolutely not happy with how they're being paid and how they're being treated, and they're abusing the machine? Is that going to impact that predictive model? Because I bet you that kind of abuse of the machine, or how, for example, it has to warm up before you can use it. Of course, they don't let it warm up because they don't care about it. So they use the machine in a cold state, and that has an impact on the different parts. Just saying something, imagining something. So is that in that predictive model? I doubt it. That predictive model, oftentimes, I bet, is applied to an ideal scenario of that machine. Now, I agree, machines are not going to, they're not in the outside world walking around or, being impacted by it. They're in a factory in a very specific contained situation. But even there, it could be that that particular machine is treated in such a way that the model didn't account for. And so then the perfection of the model may not matter if somebody's abusing the machine. Now, I want to go real quick to the personalization because we're running out of time.
Yep.
What we tried to do was this. Suppose you go into a store, a clothing store, and the salesperson, if it's a good store, right? So a high quality boutique store, not, whatever, not some Walmart or something. And the salesperson, and you say, hey, I need new clothing. I want to buy a new outfit for a big event, anniversary or something. Now that salesperson is going to size you up and is going to look at you, going to look at your body type, how you express yourself. Are you bold? Do you wear a lot of bold colors, or are you very subdued? Formal, not formal? Are you thinner? Are you thicker? Do you have a big face, a long neck, whatever, and all that? And then that person says, I got the right stuff for you. And then it goes to the rack and then gives you a couple of things to try on. You may or may not like it. So there's a matter of taste, but it probably fits your persona and your body really well. Okay, that's the kind of thing we try to achieve with the personalization algorithm, and we broke it down into 3 areas, and I'll go through it really quick because that's where we had to codify a lot of the domain knowledge of the different experts.
Okay.
And we augmented this with machine learning, or for example, the US Census data or other kinds of data that we were getting our hands on from designers or from the click and online behavior. At some point we had 100,000 visitors per month. So they click and they do stuff and you collect that too, but you still have to contextualize that. And to give you one example of how we use that click behavior, we worked with, I think I forgot what the name was. They had IP location, but the IP location is normally not so well defined. So you can find a city with it. You may be lucky to find a zip code, but you're not going to find the street. What they did is they worked, for example, with a pizza delivery service.
This is the digital element people for digital element?
I think it was, yes.
The geolocation software.
Yeah.
Okay.
We used geolocation software from them. And a couple, a while back, I think it was them, or I remember talking to them, but I'm not sure it was them or somebody else. Okay. In any case, it was verified by the real world. So
yeah, they verified. I remember in the case study you mentioned digital element for physically verifying the IP addresses.
Oh, okay. So maybe it was them, maybe not. But in any case, you had an IP address that was linked to a street and to a zip code. Okay. And one of the things that we did was, if a visitor visited us and it wasn't mobile and it wasn't a VPN and blah blah, then you could find out, in America at least, where they lived. Okay, and so if you look then at what they looked at, you could infer certain things from them. Let's say somebody comes from a neighborhood with a middle-class income and they're looking at $10,000 pieces, and they do that not once but twice or 3 times. You could assume maybe it's an aspirational buyer. So maybe they come back because they really like it. And an aspirational buyer might buy once or twice in their lives something. So how can you connect with that customer, with that visitor in that way? There's neighborhoods that are totally hipsters. And even though hipsters think they're very unique and they all differ, there's actually mathematical papers how you can cluster hipsters from particular behaviors and tastes and preferences very, very quickly. So what we did is we broke it down in 3 different groups. The first group we called the style tribes and fashion groups and personal physical attributes, and both had experts, and both have different types of experts. The fashion experts and the personal stylists that tell you, hey, you have a rounder face, that you shouldn't wear long earrings, but you should wear short earrings, or you shouldn't wear a sweater, but you should wear, I don't know, a t-shirt or a vest or something, and that kind of expertise was extracted from these experts and then codified into the system, rule-based or otherwise. I'm leaving that out right now because else we don't have time anymore. The second part was lifestyle and trends. So the lifestyle is, the trend, for example, is the Marina girls, which is a particular zip code in San Francisco. 2020, they buy a lot of pink. Now, yeah, that kind of pink would mean either they want to accentuate that, or they want to take a contrasting color. And then that's where you see that the design elements come in again, because the color was one of these things that each item was labeled with, okay? And the dominance of that color as well. So is it dominantly
but green? Even in the Beverly Hills zip code, everybody, you cannot say everybody is going to buy the same thing, especially they have the money and they want it to be very unique, and they don't want anybody else of their neighbors to have anything close to that.
So there's that. But a lot of items were one of a kind. So in that sense, they got something unique, but it doesn't mean that preferences and tastes and what is in style or not, or trends, aren't being followed, right? So that was the second group, the trends and the lifestyle. And the third was personal preferences, and that was based on the data. So, most people know what they like because they know it looks good on them, okay? So it's hard to change people's mind in that way. It's better to go with what they already think they like, and to use that kind of data in combination with the other groups. So, for example, to give you an example, let me look this up real quick because I had a couple of examples written down. So, for example, somebody can express themselves in a very bold way, bright colors, clothing and everything. There's still a difference in bold, let's say in Oklahoma City, and bold in New York City. And there's a difference in bold when you're working as an attorney and bold when you go out on a date. And it could still be the same woman. So what we also did was we looked at, we recommended based on a session instead of a lifetime. Because right now they could be looking for something they want to wear on the date. The next time it could be a very different purpose. So if we start mixing that up, you might actually give the wrong recommendations. So that was one of the types. If you talk about let's say take a design element like spikes, that fits in rebel or alternative tribe. Yeah, it's a very strong and powerful look. It's a force to be reckoned with. Now, if you're more of a feminine or a girly girl, that might not be the type of design that you would want to wear, or that fits you, or it fits with particular body types and particular types of clothing and not with others. So these kind of expertise is very, very hard to discern from the data alone. You could, if you have millions and millions and millions of visitors per month, you could extract that. But you can also look at the collective experience of all these different expert groups. So we had 5, 6 different expert stakeholders, so to speak, in a product management approach. That collective experience is gigantic data because it's learned over a lifetime. It's shared with peers, other experts. What do you think? So there's a lot of data going back and forth until they come to the level where they can recommend certain things to certain people. And rather than trying to...
a very important point, I know we are kind of reaching the end of the hour and people have been awfully quiet. So I just think this has been amazing. They're taking it in, and obviously people will give me feedback. And if it makes sense, we can continue this discussion. I can bring you back because I feel like we've not done justice. Because when you gave me the case study, you said 3 different revs of what we did and you summarized that for me. And for me, it's mind-blowing when you're talking about how you thought through the process to build that data, to build the algorithm. I did not catch that you had done clustering in the middle, right? Before you arrived at just the personalization model. And one last point you were talking about the experts who are category managers. We had category managers for electronics, for fashion, and various categories in eBay, and they brought years and years of experience, and also the experience from networking with their peers, working from other industries. So we've not touched upon it. I would like to go back to that point, because it's very easy. People say automation and everything is run by machine learning and jobs are going away.
It's bullshit.
The experience the category managers bring cannot be replaced by machine, not directly, right? So I want to understand, how does the category manager augment that intelligence so that it is in the end good for business and they bring their experience and it's not a replacement of their job? I would like to understand that. Maybe we can talk to some real category managers. I would like from your experience of how you worked with that, because you mentioned that point, but we're kind of reaching the end of the hour. So do you want to say?
So we brought them in, and of course it's funny you said that, because they were in the beginning not eager to share. We talked to personal stylists in Milan and in London and New York, and of course, you kind of talk, but then they say, well, what's up? Are you kind of trying to automate my job away? So now you have this online stylist, and so what am I going to do? And it's like, well, first of all, we're not a huge fashion site with all the fashion, so it's just jewelry, and it's a particular type of more fine jewelry. But second, that there is so many of these associations. Look, Gary Marcus, which is one of the thought leaders in artificial intelligence, and he complains, or he criticizes deep learning a lot, because he feels that deep learning is making claims that aren't exactly justified. Now, that whole debate aside, which is a bit of a tribal debate, he does make one point clear, that is, the current machine learning algorithms, that includes deep learning, but any other type of machine learning, doesn't have any innate knowledge, doesn't understand causality, can't do causal reasoning, generally speaking, can't apply common sense, and doesn't understand context. So computer vision doesn't really understand what it sees. And with this kind of thing, like the fashion and jewelry, whatever, and anything that's design related, but probably so many other product and topical areas, there is a lot of context, and there's a lot of innate knowledge, and there's a lot of associations we make subconsciously, which by the way is 90% of our thinking, that draw that conclusion, which we then rationalize. So we make it subconsciously on an emotional level, we associate things, we feel it in our gut, which is exactly that emotional thing, and then we rationalize it and say, well, it's because of this and this and this. But the rationalization is usually a huge reductionism of what's really been going on. And now we're saying that huge reductionism, that can actually, the algorithm can do that. And even then, it can't do all that reductionism. So we take, we reduce it even more. And now it's going to replace that human experience and human knowledge. It's going to be very, very, very hard to do that.
So I know many colleagues of mine from eBay have gone off and built startups in the fashion space, and many different startups, because we need many, right? It's not just one generic startup. It's not just price based that you have, or unique items only, right? So I know somebody who's looking at a startup for prom dresses, and so it is expensive purchase, and it is one time in the lifetime of that customer,
Exactly.
But they are going to spend, and they're thinking of how they like fashion, on where it comes from, their preference, and it would be a big ticket price sale, and they want to augment the intelligence of the category manager, who understands that, who are like personal assistants in Nordstam, who would walk around and understand you in a minute and give you 3 options, which the machine cannot give, and they can capture that in machine learning. So this is a very fascinating area. We are at the end of our hour. I will follow up offline for feedback with everybody, but I'm sure we're going to bring you back, because this conversation, you basically like opened up. You shared with us how you did personalization. I loved how you actually thought through the process and business acumen to build the data, to arrive at the models, did clustering of the similar items also. So you did some kind of regression, looks like, before you got
Yeah.
personalization.
But the clustering, this, what's the word similar mean? And we had a long discussion of similar, but
Yeah.
it starts there, and you can't leave that to a data scientist. You really have to have the business people or the product managers, whoever, the business people say, oh, this is what we consider similar. This is what feels good to us. That needs to be the outcome. And then that drives the machine learning and data science project. Not, hey, we have all this dark data. It's somewhere in there. We have stored all this stuff about the product. So let's just find out patterns between what we have stored in there. And that's a great predictive algorithm. You think, yeah, but why would it be? Why is that even a good? If you talk about biases in algorithms, they're not just racist biases, like, the white young dudes versus the older colored women that have the worst, like, face recognition or whatever accuracies. It's also biases in just the stuff that's stored in a database and then is being used to infer a trend or predict future sales or demand forecasting or whatever, because it was never created with that intention. So you first have to mold it to get the right intention out, and that it's neutral, and then you can do your machine learning and
so
data.
I need to wrap up for today. You've touched upon the labeling, how it is done with the human centricity, the actual arriving at the data to build the models and to iterate, and the tension that exists between the business people and the quant building the AI researcher building the model, and how that collaboration can work. And then this fear that maybe there is you're replacing my job when I'm giving you the business acumen to actually add that to the data. We barely scratch the surface on that, but all that comes into play in the enterprise, in every possible industry, though we're talking retail here today. But this is fantastic stuff. So we will pick up one of these threads and continue on into next week.
Okay.
Thank you so much, Patrick. I really appreciate this. And everybody who's been quiet watching, but thank you for all your compliments for the book. I appreciate that. And Patrick's case study is in the book. So hopefully you'll get to try it. Yes, Patrick.
I want to thank, this is a team effort. And so C. Friedrich and Marana, who was the creative director who led all the design students in the Design Academy, were an intricate part of this. So it wasn't just me, or I wasn't the product manager. It was a team effort, because as you can hear, it's such a complex story. One product manager, I don't think, can really, think of all the options and think it through. Okay, so
thank you. We mentioned them in the book. So thank you to your team.
But I still want to.
And for people who are thinking about, one of the things that I focus on AIX is think about pivoting to AI. And think about how you would bring your career into AI. What does that mean for you as a product person, business person, designer, not just the person who's building the research model, but how do you work with the AI engineer to actually bring your job, to transition your job to an AI job, because there are a lot of different AI jobs. So you mentioned this last point about, not one product manager can do this. There are a lot of my students who want to become AI product managers. And so you gave us a taste of what it means, because I always say, hey, the training data is brought by the product manager. And I hear from the engineers in the room saying, no, it's not the product manager. And, it's not just we bring the data, and it's a team effort, and it's a lot of business acumen and discussion that goes into feeding that data. And then it's a test and learn cycle. So I hope Patrick inspires you on what it means to be a machine learning product manager or an AI product manager, and hope you'll connect with him on LinkedIn. And with that,
hope you buy her book. Because
thank you, Patrick.
Like this case study, there are 9 other amazing case studies and a world of additional information.
Thank you so much.
Around these case studies, because she only mentions case studies all the time. But I think 2/3 of the book is all her collective wisdom from all these years and working at eBay and Stanford and everywhere else. So there's a lot to read there.
Thank you so much. I appreciate it. So with that, I'm going to wrap up. Thank you, everybody. And we are not going to do a live on LinkedIn, but I'm going to do some follow-up threads, because Patrick mentioned so many different topics and he has so many resources. So I find it easier to share those resources on LinkedIn. So I usually have a thread going. So if you go to Driverless World School to live stream lessons from where you came, on the left you see the YouTube, and on the right you will see the LinkedIn link. Feel free to click that link and add to that conversation, and I will come and share resources related to our conversations today, so that you'll have some reference place to go back and refer. And you can comment anytime, come in and comment anytime, or tag other experts working in this space. That's how we are going to find answers together. And I believe there is global differences, industry differences, but there's a lot of commonalities in what we can share. So with that, I'm going to wrap up. Thank you, everybody. And I will see you next week. Thanks. Bye. I'm going to close out from, let me just check, yes, on YouTube before I close. Yes. Stop recording.